Yep. Hello, hello. Okay, I hope you can hear me well now. So let me just double check. Check. Yeah, it should be good. Sorry, my fault. So, what I was talking about. Uh, this is our last lecture, and today we will talk about the monitoring tools. How can they leverage them just to make our applications being monitored 24/7, and not only applications but also an underlying infrastructure. Um, So if you're talking about the virtual machines, it's pretty easy. So we have memory, we have CPU, and we would like to know the usage of them of these metrics. We can also monitor some kind of amount of services currently running on our virtual machines, and actually there is so many stuff. But if you're talking about the Kubernetes cluster, some of the metrics are already exposed, and the only thing is left is you need just to fetch them and visualize them anyhow. So in any convenient way, for you. Um, and what can be exposed? So actually, you can expose almost everything from the Kubernetes. So the amount of deployments, the resource usage, any limits of these resources, amount of pods, actually just almost whatever. And let's have a look at our today's agenda. So first of all, we will talk what is monitoring and why do we need it. Next, we will talk a bit about the dashboard. So is it just a fancy thing which is usually used by managers, or can they somehow benefit from for such kind of some such kind of entity, I'd say. And next, almost in the end, we will have a look at the AWS DevOps course. So we will try to overview what we've done so far. And for sure, we'll talk about the task number 7. So we will try to figure out what's supposed to be done and what are the cross-check evaluation criteria. Okay, so let's start from the monitoring. So first of all, monitoring is a set of tools to monitor your environment, which is used to run your solution. And monitoring must be well visualized to determine possible trouble causes at a glance. So as a systems engineer, you usually know how to run any particular application and what are the services running, supposed to help this application to be running up and running safely and securely. But if you're talking a production environment, there is always how we call it. So it's kind of support engineers. So it's a guys. So for example, L1, L2 support. So this is a guys who is usually just looking on all of these lights on all of these dashboards and trying to understand if everything is okay. And then they get an alert. So for example, your application is just not operating normally anymore. What they're gonna do? So we just gonna try to figure out. And usually, actually, they have a kind of instruction. So if you see this, do this, and so on and so forth. But it's usually it's your responsibility to make their life as easy as possible, to make their job as easy as possible. So you should make your monitoring tool to be able to provide all of the necessary information in case of something just going wrong. It also must be comprehensive. So if we are talking about the monitoring, it must be comprehensive to cover as many critical metrics as possible. So yeah, for sure, you can monitor just CPU and memory usage. But sometimes it's cool just to understand, okay, so maybe you have a chance to set up some kind of remote monitoring. So you will have a distant server, which will usually just ping your application or just try to make API calls and verify if they are going fine or not. And your monitoring for sure should be durable, to not to lose your monitoring tool if something will go wrong with your underlying infrastructure. So it's a good idea to somehow back it up, or maybe create a cluster of virtual machines just to support one monitoring tool. So since we already started talking about the support engineers, as I already mentioned, so usually first step or the first line of this guard is L1 support. So it's not that experienced people, usually engineers, who is responsible only to take an alert and make some actions by following some simple instructions. So, okay, if you see the red light, so it's time to call to someone and tell him, okay, so there's a red light, or maybe run some pipelines or just something like this. The next line is L2 support, and usually it's an engineers who can try to understand what really happening. They're not usually following some instructions, but they have some experience and they have some understanding of how it works, and so they can go and check if the service is running. So, do we have any connections, or do we have maybe any network issues, or just something like this? And then there is L3 support usually. So, for sure, you may have a further counting of these lines of support, but usually third line of support is responsible just to understand what really happened and how it happened. So why are we talking about the support? Just because the monitoring is usually used by them. So, and you should make these monitoring tools to show as many information as comprehensive as possible, just to make the job of these guys as easy as possible. So, and if you're talking about the dashboard, so for sure, the dashboard is very convenient if you're talking about some persons who is not into this solution. So, for example, this one I just took from the internet, and as you can see, there is mostly everything is green and everything is good so far. But it's your responsibility to make these dashboards as visible and understandable as possible. So you should create as many metrics, as many these gorgeous and schemas and all these tables as possible. So just to make even for you. So for example, your application just went down and it's 3 a.m. and you're sleeping, and then you're getting a call. So okay, it looks like your solution is down. And when you wake up, you'll need such a tool in which you can have a glance and understand what really happened. So this is why the dashboards is quite important thing in systems engineering. Usually we are talking about the monitoring in the end, but it's still a very important part of almost every solution, just because it makes your life much easier. And if something will go wrong with your application, so such tools even can store some logs. So you may lose your volume, for example. I don't know, anything may happen. So even in your Kubernetes cluster, your volume will just go down and you will lose all of the logs from your application. But likely you will have an option just to transfer these logs to your monitoring system, and they will be stored in there, and you will always have an option just to have a look at these logs and try to understand what really happened and why did your application went down. And okay, we will talk about the exact solutions, I think, in the task overview when we will talk about Prometheus and Grafana, which we'll try to install in our Kubernetes cluster. But now let's have a look at our course overview. So at the first task, we worked just with Terraform, GitHub Actions, and we also touched some AWS. Next was the same, and finally we started to work with Kubernetes, and in task number 4 we touched some Helm and started to use Jenkins, and in the end, I don't know why Jenkins stopped in task number 6, but we will have a look. I believe we should still use Jenkins to deploy these monitoring tools, but I'm not sure. Okay, so we'll have a look at it. Yeah, and in the end, we will talk about Prometheus and Grafana. So Prometheus is a thing just to expose your metrics, and Grafana is the tool which is responsible to take these metrics, store it somewhere, and visualize them. Okay, so I believe now let's have a look at the task itself. If you have any questions, so feel free to ask them while we are not switched to in our task. Okay, so let me place it in here. Yeah, and actually, it's a good thing about AWS is where you also have some managed monitoring systems. So first thing, I believe it's CloudWatch. So it's a native, and It's not completely free, so you are still paying for amount of data which is stored on your S3 buckets, but it's usually it's free. So or at least you will not be charged that much if you not store many logs in your S3 bucket. But also, AWS can provide you with some Grafana, Prometheus, and other monitoring solutions built. And since they're managed, so it's enough for you just to go to the AWS console, just click on the button, and this monitoring system will be just up and running in a couple of minutes. You only need to provide some parameters for it, and it will be it. But the downside of this approach is cost. So if you're talking about Prometheus Grafana, they are open source, so you can install them without any charges on your virtual machines and just use them. But if you're talking about the Prometheus and Grafana as a service in AWS, so yeah, you will be charged for these deployments, and you will also need to pay for the virtual machines which are underlying these deployments. Okay, so let's move on to the task. Task number 7. Okay, so another objective is just to install Prometheus Grafana in our Kubernetes cluster. We are already have some Helm charts, which makes it kind of trivial action. So you can just get this Helm chart and then just install Prometheus and Grafana, and it will be enough. So you will already have an access and to your data, and you can visualize it and make some alerts, some actions in case of something will happen with your application, and so on. So first thing we need to be done is install Prometheus. So following the instruction, actually it's pretty easy. When you need to install the exporters. Exporters is from terms of Prometheus is kind of services which are exporting metrics. So you can export almost everything, even if you have your application. Okay, so currently we are talking about the Python application, which is just running Flask and saying hello world. But if you're talking about some production environments, some real applications, so you can still expose some metrics about, for example, how many online users you have right now, and how many tickets were created in your ticket system. So almost just everything. So it's up to you what to expose and how to expose. And Prometheus exporters, metrics exporters can help you with it. Next, you will need to configure Prometheus to get metrics from Kubernetes components. And the components, when understanding the deployments in your Kubernetes cluster. So in our case, it will be Jenkins deployment. It will be in our application, and I think that's it. You can also actually install the Jenkins plugin, which will give you an option to expose Jenkins metrics via the Prometheus. So you will have an option to get Jenkins metrics. So for example, how many jobs you have, or how many jobs were ran today or yesterday or in some amount of time, how many of them were failed, and so on and so forth. And then you can build you can get not only graphs, but even build some so visualize this data. So you will always have an option to just go to your dashboard and understand, okay, it looks like everything is red, so something needs to be done with my pipelines. And you also need to verify the metrics collection. So metrics usually exposed via the API, so you can find the URL of your Kubernetes cluster and specify the port. So all of them should be exposed via the port, via the Kubernetes service. And then you can just put it in browser and just find out the metrics from your Kubernetes cluster, from your deployment. Next, you will need to install Grafana. I think it's okay. Actually, I believe Alert Manager is the easiest part, but if you're talking about Grafana, so yeah, the same. You will need to follow this documentation, just install Grafana, and it should be available via it should be exposed via the Kubernetes service, and you will have an access to your Grafana deployment via the browser. So all of the installation and configuration, okay, not installation, but configuration may be done via the UI. It's pretty convenient. You will also need to configure it and create a dashboard. Okay, quite easy one. So you will find the CPU and memory utilization in your and storage usage in your Kubernetes cluster. And if you're talking about Alert Manager, so Alert Manager gives us an option to make some kind of alerts. So for example, you will have a CPU utilization over 80%, and you would like to be notified about it no matter what. And in this case, you can set up Alert Manager and create such an alert and receive notifications if some issues will occur in your deployment, in your environment. So yeah, usually it's done via the email, or there is also an option. So if you have some monitoring tools, it also may be done via the API. Grafana and the Alert Manager already pre-built with some, let's say, frameworks or tools to natively support any kind of notification outputs as possible. So yeah, and you prompted to make it via the email configuring SMTP server. So yeah, you can choose to use any SMTP server. So it's quite interesting exercise to set up your SMTP. Choose to use any you want. But personally, I would suggest, how it's called? It's called like SMTP for dev, I believe. Yeah, fake SMTP server. So it should be enough. And as far as I remember, we recently provided the Helm chart for this deployment, so you can easily just follow this one and install the SMTP server right inside of your Kubernetes cluster. Else, okay, actually, I believe I can send the link right into the chat. Okay, yeah, looks good. So once SMTP installation and setup is done, so we need to configure the contact points. We will need to provide an email whom would like to notify about some issues, and usually it should be your email, and configure some alerting rules, lack of RAM capacity on any node of the cluster, and CPU utilization, and ensure alerts are delivered to your email address. So here's the question: how to make a load enough to trigger these alerts? I think you can just set up, for example, the thresholds for this alarm for 10%, for example, and if it's reached the 10%, so you'll be notified about it. I think it's enough for the learning purposes, but you also can synthesize the load on your virtual machine or on your local PC if you are talking about the Minikube, and it may also trigger this alert, even if you set it up or on a high threshold. So for example, 80% or something like this. And verify alert, simulate CPU. Okay. Oh, okay. Yeah, we're already kind of tools provided. So yeah, you can just use any of it just to simulate the high load on your virtual machine. And as an additional task, so you can try to set all of this up via the YAML file. So currently, we only talked about how to set it up via the UI. But if you are brave enough and if you want to catch these additional 10 points, so yeah, you can go to set it up via the as a code. So you will have a YAML file where you can set all of it up, and when you will deploy your Kubernetes, your deployment once again, so all of it should be provided via as a code. And document the process as usual. So documentation is a must. Submission as usual. New branch from the main one, and provide README file documenting the monitoring, blah, blah, blah. Ensure that all personal data such as email address and SMTP credentials are hidden in screenshot. Okay. If you are talking about Prometheus, so you should provide a pull request with automation of a monitoring tool deployment Kubernetes with infrastructure as a code of CI/CD pipeline. So yeah, it's a good idea to practice just to deploy all of this stuff via the Jenkins or GitHub Actions pipeline, but it's up to you. Provide an output of kubectl and git spaces, blah, 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 and verify if Grafana and Prometheus are in place. We're running Prometheus and Grafana. And here we have, Okay, so it should be separated, but yeah, never mind. Include a screenshot of any metrics Gnode disk shown in the Prometheus web UI. Okay, Grafana. Close screenshot of configuration Prometheus data source configuration. Close screenshot of the dashboard created. Include a JSON file of the dashboard layout. This one doesn't make any sense if you'll succeed with this one, but yeah, you always have an option to export your dashboards as JSON files. So there will be the explanation on how to, let's say, draw your dashboard, and you can store it somewhere. And no matter what will happen with your Grafana deployment, you will always have an option to import it and have your dashboards up and running once again. And as for alert manager, include in the pull request screenshots of contact point, alert rules in normal and firing state, alert rules configuration, and received email. Good. If we are talking about evaluation criteria, installed up and running Kubernetes cluster, automation of deployment infrastructure as a code or CI/CD pipeline is created. Infrastructure as a code or CI/CD pipeline. Actually, Helm is also kind of infrastructure as a code. Okay, so if you will see the Helm charts fulfilled the information enough to deploy Prometheus, Grafana, and Alert Manager. So yeah, go ahead. So just give this 10 points. Grafana installation. Point to the existing Prometheus installation is added. Okay. Dashboard creation, additional task. Admin user password is created with separate secret. Okay. Alert rules configured to send alert to the following events. Configured to be delivered to your email, and the infrastructure is a code for an hour alerts documentation. Yep. So there's a question. So guide mentions AWS SES for sending emails. Can we use? Yep. Why not? So it's quite convenient way. I'm not sure if it's going to include in free tier, especially since AWS just introduced a new free tierness of their infrastructure. So yeah, just pay attention if it's okay. Let's have a look together. So let's go to the free tier AWS SES. It started for free. Okay, it's included in free tier. It started since July. Yeah, so it's free of charge. So yeah, just go ahead. Quite convenient way. But if you want to practice setting up SMTP server yourself, go ahead. It's up to you. Okay, that's probably it. Do you have any questions? I'm not sure if they have any instructions on visual assets, ethical, let's manager. Okay, I believe I'll prepare an instruction on how to remove all of the resources which were created during this course, just to verify if you are good to forget about your AWS accounts for some reason. So yeah, I'll provide it to Discord channel. Can Mailhawk be used as a local SMTP solution? As far as I remember, yes, but I don't know. I just can't recall why did I stick to SMTP for dev. Just because we're serving almost the same purpose, so it's kind of SMTP server which you can use for your tests, and don't care about some certificate security and so on and so forth. Haven't found any Kubernetes-related details in official Prometheus docs. Can you please clarify which article we need to follow? I'm not sure, but let's have a look at the task itself. So as far as I remember, we have this. We have this documentation. Okay, yeah, and the question is how to set it up. Okay, I will have a look, but it's also worth looking on here. So there is the Helm chart and the explanation how can you deploy it right in your Kubernetes cluster via the Helm. So try to follow this one. It's located in the on the bottom of task7.md. And then install instructions specifically. I didn't catch this one. Could you elaborate a little bit? Okay, if you will not fight it out, so reach me in the Discord or just ask in any of the channels. In any of channels. Oh, okay. Yeah, cool. So very good. Okay then. Do you have any more questions? Yeah, it's pretty interesting what AWS does to the free tier, to the new one. So it gives us so many new options about the AWS courses entirely. Just because we don't need to stick to these resources which are included in the free tier. Okay, yeah, I believe I'll prepare some survey or something like this. So if you will have a couple of minutes just to answer some questions, it will be very helpful. Maybe not for you, but for the but for new students. Hmm. Just because, yeah, $200 is $200. Okay, then. So if you will have any more questions, feel free to ask them in the Discord channel, as usual. If you have any difficulties, reach me directly. I will try to help you to solve your issue. And thank you so much for your patience. So yeah, it was a pleasure every Monday to be with you today, and I'm very grateful, thankful for you to be here every week. So yeah, it's kind of joy for me. And I wish you good luck. If you have any questions, yeah, feel free to reach me directly. Thank you so much, and have a good rest of the day. See you. Cheers.